Hello, this is a video for SOEN6441, Advanced Programming Practices. This is for week 8. In this video, I'm going to present the requirements and the statement for build number 2 for the project. So, let's share the screen. So if you see on the Moodle page on week 8, you see the handout here. That's what I'm going to be describing here. So here I'm going to just go quickly over the whole thing. If there's going to be more discussions in class, I'm going to be expecting that you're going to come up in class with some questions. If after class you have some more questions, I can then answer them by email, or you can come to my office hours on Wednesdays from 10 to noon. So it's the same idea as the for build number 1. So you have to essentially increment upon what you had done in build number 1. There are some things which you did in build number 1 that I did not list here. So it's assumed that these things that you already had working in build number 1 are still working for build number 2, because we're talking about incremental development here. So whatever you had that worked before should still work. I have listed some of them, but not all of them. So even if they're not listed, they should still be working. Everything that you had working for build number 1 should still be working. So you still will have to do a presentation after you submitted the code, and it's going to work exactly in the same way. So let's make this a little bit bigger. Okay. So it's organized in the same way. So essentially, you have the grading of the essentially your presentation, which is about 5 marks. Again, here you're graded upon which how much you are effectively prepared for the presentation. So if there's a lot of struggle during your presentation, you don't know exactly how to proceed, you run out of time, you will lose marks for this. As you have to explain things in your code, if you are struggling with the explanations of your own code, you struggle to find the code that you have to explain, you will also lose marks here. That's how you can lose marks for both of these things here. Now, this is the statement of the functional requirements. Okay. There are some of the requirements that are actually about, yes, providing functional requirements, but I'm giving you some design restrictions. Like, for example, here I'm saying you should implement something here, but implemented using the state pattern. Here I'm saying you should implement this, but it should be implemented using the observer pattern. Here you should be implementing this, but it should be implemented using the command pattern. So yes, these are statement of the requirements, the functional requirements of what you must implement. But here for these 3, there is some design restrictions. If you implement what is required functionally speaking, but you don't do the pattern that is explained here, you will receive at most half of the marks. Okay, so if you implement what is stated here, but it's not a state pattern, you will have automatically C. Okay. Even though if it's working, it must be a state pattern. If it works, but it's not a state pattern, you will receive maximum C, because the grades, I remind you, are A, B, C, F. Okay. Okay, so let's go into the list. I'm gonna go quickly. I'm not gonna go explain. I'm not gonna explain everything. Okay, especially the rules of the game. I'm not gonna explain them in this video. I'm gonna assume that you know the rules of the game. If there is some questions, we're gonna answer them in person during the lecture time or during office hours, or if you send me emails. So first functional requirement, you must refactor your code to use the state pattern to implement the phases in the application. So for example, you have this map editor phase and you have the gameplay. So these are two phases in the use of the application. So it should be possible that you start this application in the map editor phase. So then it's going to be in this particular phase. So there are some commands depending on what phase you are that should be invalid. For example, if you're in map editor phase and then you issue a command like game player during map edition, then it's going to be in the wrong phase. And then this command should be rejected because it is not issued in the right phase. Now, you may recognize in what I'm saying now, the example I gave about the state pattern in the video where I described the state pattern, which was describing exactly what I'm talking about here. Now, it's important that you realize that this example I gave is not exactly the same game as we have here. In my example, it's more describing the game Risk, not the game Warzone. In the way I describe it in the state pattern, it's not the same phases. Okay, so you will have to adapt the example I gave in the state pattern example to the different phases in this particular game. Okay, it's not the same phases. Important that I'm not saying to you here, you must take the code example in the state pattern and then make your code do what this example is doing. This is just one example. What you must do is to look at this example, see how it's organized, and then introduce the same organization inside of your project. So there is phases in the map editor and then phases in the gameplay. The gameplay phase must be divided in the following phases: startup, issue order, and order execution phases. So there must be at least these phases here. You can add more phases if you want, but you must have at least startup, issue order, and order execution. The context class, if you remember from, or if you should look up into the state pattern, in the state pattern, there is a class that is named the context class. The context class of the state pattern in your implementation must be your game engine class, whereas the state class in the state pattern should be a new class that you add, which is going to have to be named phase. Okay. So your different states in the game implementation are going to be objects of type phase, which is a new class you must introduce. And everything must work in the same way as a state pattern is actually working. So please look at the video and study the state design pattern in order to do this here. So important to realize here, I started this with refactor. So this should be a refactoring operation. So you should actually be doing this before you start anything else. So essentially, you will take your existing implementation, which already manages, for example, you already have a game engine that manages the flow of execution. What I'm telling you now is that you must reorganize the flow of execution, how the game engine is managing the flow of execution using this state pattern. And you should do that before you start implementing anything else for this build. So essentially here, I'm telling you, you must do a refactoring operation between the two builds. Here I'm pointing you to some refactoring operations. Introducing the state pattern is one of those. It's important to realize this is a refactoring operation, so it should not aim at changing the way that the user, it should not actually affect how the user is interacting with your application. In fact, if the user would use the application without the state pattern and then would use the application with the state pattern, the user should actually see absolutely no difference in how it behaves and how it's organized and how the software is used. Okay, that should be your goal. You have an implementation after you build number one, introduce the state pattern to manage the phases. Then as the user uses this new version, sees absolutely no difference. the difference is structurally speaking inside of the software. Here I added a few marks for things that I did not give marks to explicitly in the first build. If a command is invalid, a proper message should be given to the user that explains why the command is invalid. So that includes also the fact that the software should not crash if you issue an invalid command. Second, another one is if a command has options, each option can be used from 0 to multiple times in a single command. That was already stated in build number 1, but there were no grades for this. Here I'm giving you grades for doing this, or removing grades if it doesn't work. Here, this is simply the list of all the commands that were in the map editor. They must be still there, still all be working. And if they still are working, then you would receive this mark here. It's just to make sure to remind you that these things must work still. Again, there might be some things which are not that were listed as requirements in the build number 1 statement. It's not necessarily that they are listed here, but they still are assumed to be still working at the end of your build number 2. So this is, these were general requirements, right? And these are the requirements of the map editor. And here there are requirements for the gameplay. So here I'm asking you to implement an observer. So implementation of a game log file using the observer pattern. Essentially here what's going to happen is that there's going to be an object that a new class that you're going to create that's going to create an object that is existing in your game model, essentially. And then this object, what it's going to do is simply going to contain some kind of string that describes an action. As every action is happening, you're going to output a string inside of this object. For example, the user is issuing a command, then you're going to include, you're going to create a string that describes that for example, player red has issued a deploy command to deploy 10 armies on country number 1. Okay. So it's essentially a string that describes an action that happened in the game. So for any action that happens, you should actually update this object of type log entry buffer. Okay. So you have your log entry buffer. Every time something happens, you put a string in the log entry buffer. Then the log entry buffer should be an observable, so that if you change its state by changing the string, then the observer will actually be notified. And what the observer will do is to take this string and output it to a file, thus basically creating a log of the game as things are happening in the game. Okay. So you should implement a log that is implemented using an observer pattern. If you implement a log and it's not observer, you'll have maximum C as the grade for that. Another one, refactor your code using the command pattern. So for those of you who saw that the video when I described the command pattern, I actually designed my example so that it actually is geared toward this idea of orders in the Warzone game. So the issue here is, the point here is that the orders are actually managed as commands using the command pattern. Okay, so when you use the command pattern to manage your orders, the orders will be the commands. Each of the specific kind of orders will be concrete commands that are created. Now, who creates the orders? Basically, who is the invoker of the commands of the orders is the player. So the player is creating the orders, which is the invoker. The player is the invoker of the commands in terms of the command pattern. And the client, which is the one that will eventually execute the orders, is the game engine. Okay. So if you look at the example of the command pattern I gave, which is available on the website, you will see that it tells you a lot of hints about how to implement that as a command pattern. Okay. Again, if you implement the orders, which are generated by the player and then which are conveyed to the game engine, but it's not actually using a command pattern, you will receive at most C for this particular requirement. So yes, commands must be created by the player and then executed by the engine, but also it must be managed using a command pattern. New requirement, all players have a hand of cards. So I'll let you figure out how you will implement a hand of cards. So essentially the player should have some kind of array list of things that are cards. How you will implement cards, I'll leave it up to you. Will this be objects or just simply a string that describes what kind of card that is? Up to you. Okay. It does not have to be a class card. Maybe it's better. I'll leave it up to you. So the idea is that players, when the game starts, the players start with no card in their hand of cards. Okay, it's not the kind of cards that you deliver to the players as the game starts. The players start with 0 cards. Then how do you get cards? Every turn, if a player conquered at least one country in their turn, they receive 1 random card, meaning maximum 1 card per player per turn. So in your turn, you, for example, issue advance orders. As a result of an advance order, if you advance some of your armies on a neighboring enemy country or territory, then it's possible you will conquer this territory through this advance order. If you do, then at the end of your turn, you will get 1 random card. Okay. You don't get one card per territory you conquer. You get 1 card in your turn if you conquered at least 1 country. That's how you get cards. Eventually, we'll see how you can use the cards. So there's the gameplay command show map, which must still work. You're supposed to have that from build number 1. It must still work in build number 2. For the game startup phase, as you did in build number 1, you should have still these 3 commands here that are working in the game startup phase. So you see that this is one of the phases that are managed by your state pattern as expressed on top of the requirements. Then for the reinforcement phase, so in your reinforcement phase, as a player starts their own reinforcement phase, every turn, they would actually get a certain number of armies depending on how many countries they control, and if they control entire continents. Okay, so again, you had done that in build number 1, it must still work here. Then here, there is 2 new things here that must be added, or at least many things are added here, and this one is being made more clear or complete here. So for the order creation phase, in the build number 1, the only order that you could have is deploy. So I'm giving you 1 mark if it's still working here. Then you will also have to, in build number 2, implement the advance order. So advance is about moving armies from one territory to another. If you move from your territory to another of your territory, it's just basically moving the armies to this other territory of yours. If you move armies from one of your countries to an enemy territory, then there's a battle. After which it's possible that you will actually conquer this territory, in which case you would get 1 card, and then this territory would now be yours. And then the surviving armies of the battle will actually be moved to this conquered territory. That's evidently the most complex order to implement. It's not very complex, but that's the most complex of the orders. Then you also have card orders, because if you remember I invite you to look at the description of the project that we have covered in the beginning of the course. So there's the bomb card, the blockade card, the airlift card, and the diplomacy card. Each of these actually enable you to create an order. So for example, you can issue the order or the command bomb country ID. So you say, for example, I am, I don't know, country A, and then I have an adjacent enemy country B beside my country A. So I can say bomb B. Okay. And the effect, as we saw earlier, I'll let you look at the effect of all the orders here. The effect is that the number of armies on this territory would be reduced by half as a result of the bomb. Now that assumes, so this is an order that you can issue. This is an order this is a command that you can type. Okay. So as the player is playing their turn and you come into the order creation phase, then the player would actually enter this command, and then the command has to be validated. And part of the validation of using the commands that require a card, you must check that you have, for example, if you issue the bomb command, if you type the bomb command, then if you don't have a bomb card, then the command would be invalid. Okay. Essentially, the fact that you have a card of the type that enables you to issue this order is a condition for this order to be valid. So these are just basically new commands that you should add. And the effect of these commands is to create an order. And if they are a command that is associated with a card, then you must have an additional condition for this command to be valid. That is, the player that is issuing the command is controlling a card of this type. And of course, once the command is created, then the card should be removed from the player's hand. The card is consumed by the issuing of the order. So you have the bomb command, the blockade command, the airlift command, and the negotiate command. These are all new commands that you should be creating, and the effect of them is to create orders. Then each order would be put in the list of orders of the player using the command pattern. Okay. Then afterwards, after all the players have issued their orders during a turn, so the way that the order issuing phase, as we had in build number 1, is that all the players in the same turn have all said, I don't have any more orders. Then the orders creation phase would be ended. Then you go to the order execution phase. Order execution phase, what happens is that the game engine is going over all the players in round robin and asking each player in turn, give me your next order. And the player is giving the next order. So that essentially the game engine is calling the next order function of the player. Then the player gives their order to the game engine. Then the game engine will execute call the execute method of the order. Okay. I'll repeat, the orders must be implemented using the command design pattern. This conveying of the order, mechanism of conveying of the orders must be implemented using the command pattern. And essentially your orders must be a command according to the design of the command pattern. So that's it for the functional requirements. So as for build number 1, you have actually 30 marks for the functional requirements, 5 marks for your presentation, total of 35 marks. And then you have 15 marks for what I call programming process marks. So this is very similar to what you had in build number 1. So you have 1, 2, 3, 4, 5 things here. But here I've added the refactoring process element. So in the what we have on top here, so I have added Refactor. I have 2 refactoring elements here. Okay, so you must have one of your refactoring target. 2 of your refactoring targets must be the ones that we have listed above there. Okay, I'll come back to that later. So essentially, you must do exactly the same things as build number 1, except that it's slightly changed here. For example, there's more unit tests that you must have. There's more commits that I'm expecting. And then for the architectural design description, you should also document how you have actually incorporated the state, command, and observer patterns inside of your architectural design. Okay. So that's how architectural design programming process element is changed for build number 2. You must add this here, how you have integrated state, command, and observer patterns in your design. For the use of the versioning repository, now you must have at least 50 commits. Okay. So you might think this is a lot. I'm telling you, the teams that really know how to use that, they come up at the end and they have above 100 commits. Okay. So if you think this is a lot and you think, well, that's impossible, probably you're doing it wrong. Okay. So you should take the habit, everybody in your team, to do a small step and then commit, small step, commit, small step, commit, so on. So that's how it should be done. If that's what you do, everybody in the team very easily will come up with adding up to at least 50 commits. Again, I repeat, should be distributed evenly among team members. I don't want to see a single person having 45 commits and then each of the others have 1. Okay, don't want to see that. If you do, then there's going to be marked deductions. Should also be somehow distributed evenly across the span of the duration of the build number 2. I don't want to see like 25 commits in the last evening before the presentation. You should have created a tag version for build 1 and 2, and you must use a continuous integration that does 3 things. Project successfully compiles when you push a commit on the repository, the tests all pass, and the Java doc is compiled and reported as complete. The way to do that is actually when you compile the code in using the Java command, you can actually use the -x.lint command, and then the compiler will actually check that the Java doc has been if the Java doc has been generated, and if there are some places where it's missing, it's going to report it. So that's how the marker is going to give you check if the API documentation is going to be complete or not. Okay. So you must use this option as you compile your project. So the API documentation must be done for all the files, all the classes, and all the methods, including the private members. And all the tests also must be documented, not only the source code. For a unit testing framework, you should have at least 30 relevant test cases. Okay. Now, because I'm asking you to do refactoring here, for every refactoring target that you will identify, I'm asking you to have 5 refactoring targets. So you must demonstrate somehow that these refactoring targets are properly tested, because as I explained in the refactoring video and lecture, if you want to do refactoring, you cannot, if you don't have tests for something that you refactor, you cannot call this refactoring. Okay? Refactoring requires tests. Refactoring is an operation by which you want to change the design of something to make it somehow a better design without changing their behavior, the behavior of the code. And then the concept is that you target a certain piece of code to be changed, to change its design, and then you test it before you make the change, and then you test it after. So it assumes that you have tests. Okay. So all this to say, I'm asking you to have 5 refactoring, separate refactoring operations. I'm assuming that you should have at least 5 tests for each of these refactoring operations. So that's easily coming to a total of 30 tests. Again, if you think 30 tests is a lot, I'll tell you what, the teams that really know how to do the testing, they come up at the end and they have way more, over 30 tests. Okay. In real life, you easily come up with 100 tests at the end. I'm not asking you to have 100, but 30 is not an astronomical number by any stretch of the imagination. Okay, so you must have at least 30 relevant test cases. And then I'm giving you some examples, not examples, but some hard requirements as to what kind of tests you must have. So you must have tests for map validation, validation of correct startup phase, calculation of number of reinforcement armies, test for the validation of orders when you execute, such as when if the order includes a identification of a source and target territory, you should check that they are valid territories for a target for this order issued by this particular player, as well as conquering a country. For example, if you are issuing a advance order, then you should check that if this order results in conquering a territory, that it actually is result in the territory ownership to be transferred to the player that just played the order. Okay. And also moving armies in the conquered country after conquering it. Because if you conquer a country, and you have surviving armies after the attack, then these armies should be moving to the conquered country. And also the end of game, if you conquer, if you issue an advance order, which results in you conquering the last country that was not yours on the map, then it should declare you as the winner of the game. You can also, for example, create a new state of the game, which is end. And then you would actually check that after you conquer the last territory that was not yours, then that the game is now in the state end, for example. And then you must also have this relationship between a test class and a tested class. Essentially here, what I mean is that when you have a tested class in your code, it should be tested by only one test class. So if you have one tested class, you should have one test class. You should not have more than one test class that is testing a tested class. You could have some classes which are not the subject of any tests, though. And then you should have test suite. You should have one test suite for everything, and then at least one test suite for every either package or a folder that you have in your design. Then you should also still be doing the coding standards, which are, I repeated here. And then what the new thing here I've added is refactoring. So strongly invite you to look at the video, to listen to the to visualize the video for that I recorded for the lecture on refactoring that describe what is refactoring, and especially toward the end where I describe how I'm expecting that you will do that in the project. Okay, so refactoring is very important that you understand that it should be done before you start the coding of the implementation of the requirements. Okay, so you should be, first thing you should do working on the second build is do the refactoring. You should refrain from trying to implement new things. You just basically do the refactoring. So you should demonstrate that you have applied a refactoring operation after build number 1. Explain how you came up with a list of potential refactoring targets, how you chose the refactoring targets among the list of potential targets, and explain the 5 refactoring operations that you have applied. Refactoring operations must be done on code that has some unit tests in place, and a short document should be written that describes your refactoring operation. So in this document, you should list a list of 15 refactoring targets. So you should find ways to identify at least 15 things that you think might be worth actually changing in your design. There's 2 of them that I actually listed in the functional requirements. So these ones must be there. Okay? So first you list 15 potential targets for refactoring. Then you have to discuss with your teammates and then figure out which 5 of them you will choose that you will actually implement as refactoring actions. So that would be your actual refactoring targets. Then you must choose 5 among the 15. Then you should also explain what factors did you use to decide which ones you will choose and which one you will say, no, we will not do this refactoring operation. So I want you to explain how, what factors did you use to either choose a refactoring operation or reject a refactoring operation in choosing the 5 that you will do. Then for each of the 5 that you have chosen, then you should list all the tests that apply to the classes involved in this refactoring operation, and then check how many tests that you have for these classes that will have to be changed by the refactoring operation. So there should be tests for everything that you will eventually change. If there are things that don't have tests, then you should add tests before you actually do the refactoring. So if not enough tests exist for the classes, add more tests. Then you should explain why this refactoring operation was deemed necessary, and then you should give a before and after depiction of the refactoring operation. So you should explain this was the design before the refactoring, and this was the design after the refactoring. So you do that for every of the 5 that you have chosen as your actual refactoring targets. So that's it for this description of build number 2. So again, we will go quickly over that in class. Then I'm going to be opening the floor for questions in class. I'm going to be expecting that you will have some questions. If not, then you can send me emails for clarifications, or you can come to my office hours on Wednesdays from 10 to noon. So that's it for this. Thank you.